Okay, Calc, yesterday we got cut off a little bit because of, I don't know, my computer dying or whatever. And so here's the homework assignment again for section 2-4. We're going to finish the notes today. But we were on example 1. I gave you some background information, and this was the product rule one, right? So just as a kind of a review, we had F here and G here. And the rule for product rule is F prime G plus G prime F, right? So we said the derivative of 4x squared minus 1 was 8x, right? Let me just do this. Let's go. Do I have a little highlighter to talk about? Nope, this one right here. Nope, that's not what I want. I want him just to like point. Nope, that's not what I want either. Okay, well, whatever. It's fine. 4x squared minus 1 is 8x. And then just G, we just plop him in that spot. G prime, the derivative of 7x cubed plus x is 21x plus 1. That x turns to 1 when you take the derivative, and then you just plop f in that spot, okay? When we FOIL, this multiplied through ends up giving us the 5, the 57, the 8, and the not the 84, just those two, okay? Then if we FOIL these two together, we end up getting these 4 terms. And if you combine like terms, you should end up getting that last little bit, okay? 140x to the 4th minus 9x squared minus 1. And that is the derivative of this guy. Now, you could have FOILed these two to begin with and then just done the power rule, and you would end up getting the same thing. In fact, I might do that. Let's try doing that real quick, okay? If I FOIL, these two multiplied together is 28x to the 5th, right? This multiplied through is plus 4x to the 3rd. If I multiply the middle two pieces, I've got minus 7x to the 3rd, and then those two multiplied is minus 1x, or just minus x, right? Okay, now if I take the middle two pieces and put them together, that is minus 3x to the 3rd, okay? So if I do the derivative now of these 3 pieces, 5 times 28 is 140, x to the 4th. This guy's derivative is minus 9x squared, and the derivative of negative x is negative 1. And that is the same thing as what I got over there. Now you're like, why would I do the product rule if this was way faster and easier? Because eventually we'll get to the point where like doing the product rule is like way faster. Like in this next example, I would not want to multiply the square root of t through first. I would want to do the product rule on this one. So we have a product, and the product is right here. So this is going to be the F part, and this is going to be the G part. Now, before I do the G part, I'm going to rewrite this G part as t to the 1/2. I think. I'm going to, yeah, we'll go with that. All right, so yeah, F prime.
I'm going to go potty.
Okay, all right, you go potty. You just told everybody that you were going to go potty, but that's fine. G prime F. F prime G plus G prime F. All right, there is that. Oh boy. All right, F prime is the derivative of this guy. The derivative of 1 goes away. The derivative of t is just 1. That's kind of nice. Now, G is t to the 1/2 power. That is true. When I'm putting just G in here, though, I'm going to leave it as the square root of t, okay? I'm not going to write it as t to the 1/2 because we're going to have to simplify him. You can if you want to. I don't care. But I'm going to leave him as the square root of t. Now, when we go to do G prime is when I want to treat him as though he says t to the 1/2 power. So I'm going to do some scratch work over here. T to the 1/2 power, I'm going to bring the 1/2 down in front. T, and then if I subtract 1 from 1/2, that's to the negative 1/2 power, all right? To make him a positive 1/2, I'm going to shove him back underneath, right? And so he will be 1 over 2 t to the 1/2 power, or 1 over 2 square root of t. Okay, that's what he will look like. Okay, then we just have F, which is this guy. He is 1 plus t, okay? All right, now the only thing that I will do to simplify is like these two guys, 1 times that will just end up being the square root of t, plus. Now, when I do this, this is a fraction, right? So if I treat this like it's a fraction, it's over 1. I'm just going to slam those two together, and I have 1 times 1 plus t, which is just 1 plus t, and then this times 1, which is 2 square roots of t, and that's cleaned up a little bit, and that's how I will leave his derivative, okay? So that was using the product rule. That's probably going to be faster than doing the power rule, honestly, okay? And notice that they, S was the name of this equation. They didn't call it Y. They didn't call it f of x. They called it S. So they say find ds dt. That just means find the derivative of S with respect to t. So our variables are t and s instead of x and y, okay? All right, now we get to the quotient rule, and I've already shown you kind of a little bit of the quotient rule, but here is, if you want to circle him, f prime g minus g prime f. So product rule would be plus, and it's just this top guy, but but quotient rule is minus and then all over g squared. All right, so when we're doing, this one says find y prime. That's just another name for the derivative. So y is what this guy is. Y prime is what we're looking for. All right, f is going to be your top and g is going to be your bottom. Okay, now there's some things that I simplify on here and then there's some things that I don't bother simplifying. So we'll get to that. But let's go here. I got f prime g minus g prime f. Okay, all over g squared. So g squared f prime g minus g prime f. The first couple times you do this, you may want to go through and do the bubbles like I just did, so that way you know you're not missing a piece, right? Sometimes people get so cooperated with, that wasn't the right word, so preoccupied with doing g prime that they will forget to do f prime after the word, and they'll forget about this term. You'll do it at some point. I'm sure you will, okay? So put those bubbles in there so you get used to doing all four pieces on the top, right? So this is f. And the derivative of f, if I take the derivative of x cubed is 3x squared. The derivative of 2x squared is plus 4x. And then the derivative of the minus 1 goes away. Okay, that's what f is. Now I have g, which is x plus 5, okay, on the top. And then I want to do g prime. Let me get rid of this. G prime is going to be the derivative of x plus 5. The derivative of x is 1, and the derivative of 5 goes away. So that one's kind of nice. And then f is going to be x cubed plus 2x squared minus 1. He just stays, okay? On the bottom is x plus 5 squared, okay? Now, I'm going to go ahead and FOIL this top to get rid of some of this stuff, but I'm not going to FOIL the bottom. I'm just going to leave them as x plus 5 squared, all right? So the top, let me just do some of this stuff. If I FOIL these pieces right here, right, that'll be 3x cubed plus 15x squared plus 4x squared plus 20x, okay? All right, now that's those four pieces. This guy, don't forget that there's a minus there, and you're distributing a -1 through all three of those pieces. So this will end up being, because of that negative, this will end up being negative x cubed minus 2x squared plus 1. That's what we will get. Okay, and then on the bottom we've got x plus 5 squared. I'm going to put like terms together and then call it good. Okay, so 3x cubed minus x cubed is 2x cubed. 15x squared minus 2x squared is 13x squared. Then, oh wait, we got a 4x squared too. Hold on, this guy. 15 and 4 makes 19, and 19 minus 2 is 17x squared. And then plus 20x plus 1. That's what you should get on the top. On the bottom, x plus 5 squared, and we are done. That is what my derivative is. Now, keep in mind, a derivative is the slope of a tangent line, right? Like, how the heck can this whole big thing be a slope? That's because I haven't designated where I want it to find the slope at, right? Like, if I say I want it to find the slope at 2, I would plug 2 in for all of those x's, and it would give me one number for the slope, okay? So, just FYI, that's what we're finding. All of those things, but that was using the quotient rule, okay? Example 4 wants us to do a little bit more, and they say graph f of x, which they've already got done here, so that's already done for you. And use your graph to make rough estimates of the locations of all horizontal tangent lines, okay? Remember, a tangent line is a place where it touches at only one place, and I want horizontal to look like this, so I want them to be that little flat bar that's only going to touch at one spot. Well, I know for sure that he's going to have a horizontal tangent line right here, okay? But also I think he comes up to like a peak right here, so I think he's going to have a horizontal tangent line there and maybe another one right here. So we'll find out that there's probably 3 places for horizontal tangent lines, okay? All right, that is the graph of that. So that was part A, done, check. By differentiating, the word differentiate means finding the derivative. Find the exact locations of those horizontal tangent lines. Well, we've got to first find the derivative, okay? A horizontal tangent line, I'm going to write some things up here. Horizontal tangent line, I think we've been over this before. Horizontal tangent line is a tangent line that has a slope of 0, right? These lines have a slope of 0. And so basically, the tangent line has a slope of 0, and the slope of a tangent line is the derivative. And the derivative, we're going to set equal to 0 to find where those places are located, okay? So that's what we're going to do. We're going to find the derivative. We're going to set it equal to 0. This is a really ugly thing. I'm going to write him down here. x to the fourth plus 1, and we've got our f of x on top, and we've got our g of x on the bottom, so we've got to do all the things. So f prime g minus g prime f all over g squared. Okay, all right, so I'm going to write g squared. I'm going to write my bubbles, actually. That's squared. Okay, g squared on the bottom. Don't foil this out. Something magical is going to happen to him, okay? On the top, f prime, if I want to take the derivative of this, derivative of x squared is 2x, and the derivative of negative 1 goes away, so there's that. G is x to the fourth plus 1. Cool. Then I've got g prime, and the derivative of x to the fourth is 4x cubed, but the derivative of plus 1 goes away, right? And then I've got f, which is x squared minus 1. All right, now I'm going to fix this top, right? If I distribute my 2x through, I've got 2x to the fifth plus 2x. Okay, now don't forget that this minus goes with the 4x cubed. So I've got to distribute him through. That's going to be negative 4x to the fifth plus 4x cubed all over that junk squared. X to the fourth plus 1 squared. Okay, so there's what we've got now. Now I'm going to put stuff on the top together. So if I do this guy and this guy, that's negative 2x to the fifth plus 4x cubed plus 2x. What?
Mom, do you know what happened to Boo?
What, bud?
Hello, Grammy.
Hey, can you wait just a minute, bud, to tell your story? Okay, just wait. Just wait. Talk to Grammy real fast. I'm almost done with this. Okay, I'm going to make sure I didn't screw something up here. Nope, we're good. We're good. We're good. Okay, all over that stuff. X to the fourth plus 1 squared equals 0. Okay, all right, now, why equals 0? Because the derivative we're setting equal to 0 to find out where the horizontal tangent lines are. Okay, so when we are setting him equal to 0, we hate fractions. The first thing we're going to do is we're going to multiply that stuff to the other side. X to the fourth plus 1, we're going to multiply that to the other side squared, like that, right? But then he's gone, right? If I multiply him over here, x to the fourth plus 1 squared, he's going to go away, and he's just going to be equal to 0. Negative 2x to the fifth plus 4x cubed plus 2, okay, x. And then I've got to simplify from there, all right? So let's see. If I take out a negative 2x, I will be left with x cubed plus, no, minus 2x squared. No, wrong. Did I do? Oh, this is x to the fourth. X to the fourth minus 2x squared minus 1 equals 0. Okay, so then I set those two equal to 0, and this makes it kind of hard because this guy equal to 0, negative 2x equal to 0. If I divide by negative 2, that's where I get x equals 0 from. But if I set x to the fourth minus 2x squared minus 1 equal to 0, that is a little bit messy. Kind of, not really, a little bit messy, okay? I think we did one of these in trig the other day, right? So we're going to pretend for right now that instead of that saying x to the fourth and x squared, we're going to say that it says x squared minus 2x minus 1. That is a simple trinomial that we can break down. Oh, but that still doesn't work, though, because there's nothing you can multiply to get 1 but add to get 2. So we're going to do this like the quadratic formula. Sorry. Negative b will be negative 2 plus minus the square root of b squared is 4 minus 4 times a times c at 5. Are they still in Hastings? No. Oh, they're here? Okay. All over 2 times a, like that, okay? And that's going to become a positive 2. If I do this in here, that will end up being positive 4, right? So I've got 2 plus minus the square root of 8 all over 2, like that, right? Okay, so that is what x is equal to, except the problem is that's not what x is equal to, because that's if it was x squared minus 2x minus 1. This is kind of weird. Because it was x to the fourth, I have x squared is equal to that, right? So now I'm going to take the square root, and that's going to end up being my answer. The square root of let me convert this to a decimal so that you can see this really quick. Okay. x squared will be equal to that. Let's do these as decimals. X squared is equal to 2 plus and minus the square root of 8 over 2. Plus the square root of 8 divided by 2 is 2.41, okay? And x squared is equal to 2 minus the square root of 8 divided by 2. And that is negative 0.4, negative 0.414, okay? Now I take the square root of those. And x is equal to, let's see if this comes out nicely. The square root of that, and that is 1.554. I use the full decimal. And we can't take the square root of this guy because he's negative. Oh, but wait, this should be plus and minus. So plus minus 1.55. Right? Because we can't take the square root of a negative. So this one drops out, and we can't do that one. Okay? So we get this thing going on, the square root of, or plus minus 1.554. Let's see if that's where he's at up here. They said our scale is going from negative 2.5 to positive 2.5. Okay? And so that means 1 was right here, 2 was right here. 1's here, 2's here. We said about right there is where he's going to cross, and about right there is where he's going to cross. That looks like a 1.55 and a negative 1.55. Okay, now, he will not always be that ugly to break down that top part. It actually usually comes out really nicely, so I'm kind of surprised they gave you this ugly one to begin with, but whatever. So that's the moral of the story, is that they want you to take the derivative, set it equal to 0, and you can find those places. Oh, by the way, over here we said 0 was one of them also, and that's where this guy is. Okay, so we had 0. We had 1.55, we had negative 1.55. Those are our horizontal tangent lines. So if they ask for where are the horizontal tangent lines, you're going to take the derivative and set it equal to 0 and solve, okay? All right, that was kind of a messy last problem, but whatever. There's your homework assignment. Work on those for the rest of the period, okay?